All right. So let's get started. Kind of very briefly about myself. My name is Michael. I've been focused on security for low code, no code for the last 3 or 4 years now, or the intersection of those two worlds. I lead an OWASP group that is dedicated to low code, no code applications and how we can build them in a secure way. Feel free to check it out later. A couple of years ago, I started a company that's focused on this area. It's called Zenity. We are helping organizations secure their own low-code, no-code applications. I spent several years at Microsoft as part of their cloud security division. Really all around security, API security, IoT, cloud, confidential computing. And I write in dark reading. So if anything, if you find these topics interesting, there's a bunch of information that I've also put out there. If anything in this lecture resonates with you, please feel free to reach out. You can see my contacts there. DMs are open on Twitter. So before I start, this is a really important slide. The reason, of course, to understand the attacker's perspective of no code is just to make sure that we use it in a correct way. So low-code, no-code technologies are really empowering business users to solve their own problem. The impact it's having on enterprises is amazing. And so, of course, the idea behind this talk and this kind of research is to illuminate what the risks are to make sure that we do it in the right way, in a secure way. Here's what we're going to do today. We're going to start by making sure that we're all on the same page on what low code actually is or what low code, no code actually is. And we'll do that briefly. Later on, we are going to cover several attacks that were observed in the wild that were using low code, no code as the attack vector, the way to get in. We'll see attacks that are living off the land of low code, no code, or using low code, no code for an attacker's advantage. We'll see hiding within low code, no code platforms, and we'll see how we can leverage predictable misconfigurations in those platforms to gain access to corporate data. Of course, we'll leave you with a couple of takeaways. One is how to defend your organization. What are the things that you should be thinking of doing right when you live today? And we will give you tools that would allow you to test these capabilities and play around with them as part of your own red team arsenal. So let's start by making sure we are all on the same page on what low code, no code actually is. And before we go into details, the more important part that I need to convince you of is that this is actually important, that this is an area that is critical for you to invest in. And I think the next slide is maybe the most important slide in this entire talk. This chart represents the growth in the number of applications, low-code, no-code applications, representing a single Fortune 500 organization. So these are, of course, anonymized statistics, but these represent real organizations from information that we're seeing with orgs that have shared this with the OWASP group. And you can see that very quickly, in something like 3 years, almost 70,000 applications were built. The reason behind this is that it's very easy to create applications because of the drag and drop interface. More people can create those applications because business users can do it, not just professional developers. And so you end up with a lot of applications. This exponential chart, we are seeing it again and again with organizations using low code, no code. And this is also why it's important. If you compare this to application developed with to professionally developed application or applications developed with code, you'll find that the top organizations can generate 1,000, 2,000 applications per year. These numbers are unprecedented, and that's why this is important for us to know, to take a look at. And so, let's start now by kind of figuring out, making sure we're all on the same page on what low code is. First of all, low code is there, or low code and no code has been brought into the world in order to address this problem where, as a business user, you are typically under budgeted, you have lots of needs that are unanswered, and IT cannot realistically cover all of those needs. So if each one of the applications that we just saw on the chart represents a single business need, of course, no IT group can really grow to satisfy that demand. And so people are looking to solve their own problems. Now, this is not new. People have been trying to uh, to empower business users to build their own applications, to solve their own problems ever since productivity and corporate started. I mean, we started with things like macros, which are close friends as security professionals, or all sort of kind of screen grabbers. And today, this has kind of shifted and matured into applications that can be built with drag and drop interfaces, which is low code, no code. But it's important to know that this is part of a larger trend of IT decentralization, giving more people more power to build applications and automations. Now, what people are building with these technologies? Well, they're building a whole bunch of things. So they are building automation. So for example, if I get a new email or if somebody mentions me on Slack, then do something else. For example, upload something in Teams. They can do integration. So for example, moving data from one place to another. They can build business applications that facilitate a specific process. So for example, if you'd like to do a campaign across your organization to collect information from different users in the org, you can do that through a. There are entire products, customer-facing products that are built with low-code, no-code because of its ability to operate faster. There are more mobile applications. These applications can be very advanced. And one of the things you should be asking yourself right now is, well, is it related to my org? So do we use low-code, no-code? Does the typical organization use low-code, no-code? And the answer is that in most organizations, you'll find more than one no-code, low-code platform. And the reason behind this is not that each organization has to choose using those platforms. Essentially, every major SaaS provider has now become a low-code, no-code platform. So if you're using Microsoft Office 365, if you're using Salesforce, if you're using ServiceNow, all of those platforms are now embedded with low-code, no-code capabilities that are built on top of the business data that already sits there. And they are empowering business users, first of all, to customize their experience in those platforms, but also to build things on top of that. So you can build applications in Salesforce that are not related to sales. You can build applications in Microsoft Power Platform that are fetching data from AWS or from GCP. And so this has become a new type of cloud. This is available again in every major organization. This is what makes this super important, because no matter your org, if you're a large enough org, you'll see you're probably using those platforms. And more than that, in a typical organization, we typically see between 5 and 7 different low-code, no-code platforms that are actually being used. And so when we think about those kind of those platforms, one thing to understand or to think about is what is actually going on there. So first of all, these applications, we've seen that they are available in every major enterprise. They have access to business data because they are kind of by definition, they are built on top of business data platforms. They are built on top of your Salesforce or your ServiceNow or your Microsoft. They run as a SaaS in the SaaS provider's cloud. So it's difficult to monitor from our perspective as security professionals. And of course, from the security perspective, there is lacking information or lacking focus on this area, which makes it a good place for hackers to focus on. And this is what we're going to see today. All right, so we're going to, in a moment, we're going to start seeing real-world attacks that were observed in the wild. And we'll start with the living of the land attacks. So attacks where, if you think about the recap we've just did, these are platforms that have compute, they have access to credentials and data, and they run on somebody else's cloud, which is kind of the perfect storm for a living of the land attack. So we'll see that in a moment. Before we do that, let me show you one concrete example of a low-code application, so we can just make sure that we have something to think about when we go through the next phases of watching attacks. So this is a very simple application. Basically, what I'm doing here is we're using Slack in my org, and then there's this thing where if somebody mentions you on a public channel in Slack, then you feel obliged to reply quickly. So in this kind of funny little demo, I'm creating an automation that subscribes to every new mention of my account in Slack. And whenever I get mentioned, I'm going to change my status so people, as if I'm on a call, as if I'm currently in a meeting, the icon next to my name will change. So people will know that I'm occupied and that they should not bother me right now. And then just to make sure they're not suspicious, a few minutes later, I'm going to change my status back to be available. Now, this is kind of a funny joke, right? That is meant as an example, but you can see that while I'm explaining what this application actually does, on the background here, I'm actually building this application, and this is a very easy process to create. So you can see I'm dragging and dropping. You can note that I'm not logging in anywhere, so we'll touch briefly on that in a moment. But you can see that the application has a few steps. Each of these steps is creating a specific operation. Some of them are managed within this particular platform's API, and others are going out to the Slack API to actually fetch information from that API. So again, the first step is subscribing to new mentions in Slack. Then I'm changing my icon as if I'm on a call. I use a delay step to make sure that to wait a few minutes, and then once those minutes pass, I change my status back to a regular status. And once I've gone through all of that, you can see that let me move a bit, push this forward a bit. All right, so the last thing that I wanted you to see, but we'll see it later, is the fact that once you go through all of that, uh, the application is actually being deployed. So once the entire process has terminated, I just click save and the application is deployed, and that's it. There's no CI/CD, there's no pipeline, there's no security review, nothing. And so the number one thing that is interesting about this application, so maybe, okay, let's take a step back. It's important to note how sophisticated this application actually is. So it has to fetch information from different APIs and address those changes to those APIs. It has to authenticate. It has to wait around in the background. It has to subscribe to a webhook. This is a sophisticated piece of software that you can build without any knowledge of professional development. Now, the number one thing that is interesting from our perspective as a security professionals is under which identity is this application actually is actually operating. So when it reaches out to Slack, how does it look like from the Slack perspective? How do the network logs that are being generated by that action, how do they look? And you can see that I haven't really authenticated to Slack in any stage at that demo. So what really happened here? So here's what happened. When you first connect a new application to Zapier or to any other local no-code platform, you get prompted with the usual OAuth consent flow, and you can see it right here. Now, when you terminate that consent flow, you of course get an authentication token. That authentication token gets wrapped in an object called connection. And the most interesting part about this connection is that little share button that you're seeing here. So local no-code platforms allow users to share those authenticated sessions with other users and embed those sessions within the automations and the applications that they create. This means that if you look at it from the network perspective, there's no application there. It's actually using my own personal identity when connecting to Slack. So let's try and figure out how this happens. So on the one side, we have Zapier or any other local platform. This is actually a slide from Microsoft showing how Power Platform, Microsoft's local platform is operating. And on the other side, you have Slack and the REST API. So essentially what happens is that in the middle there's an API layer, an API gateway layer that dynamically switches the tokens for those that belong to a user. So an automation runs or an application runs, and when they run the connection to Slack, my user token gets embedded there. Now the crucial piece here is that I can share this automation with other users, and then those other users are still using my personal token, and there's no way to distinguish between the two. And so because and one of the things that you'll find in those local no-code platforms is a whole bunch of connection, or a whole bunch of automation. So you've seen the graph when we started. These are just a few examples that are taken out of the of platform marketplaces for types of applications that are being built. And the important thing here is to watch the icons. These icons represents connections to data or ability to perform operations on behalf of users. And so there are lots of logos here. There are lots of applications. So this means eventually you'll have lots of credentials. You have a trail of credentials that are waiting around in these local no-code platforms. And it looks something like this. So this is actually a screenshot for one of the platforms. You can see that the platforms can connect to many different places. This is basically a bag of credential waiting for somebody to log in. And you can see that this is connecting way across the specific platform that you are using. So if you're using Microsoft, if you're using Salesforce, it is not contained. It is not the local no-code platform is not contained only to data that is sitting within that platform. It can connect to other places, and many of those platforms have hundreds of connectors that are ready for you to connect on-prem, cloud, other SaaS. Data and operations are available. And so in many of these platforms, you also have a notion of a default environment, some default scope container that contains all of the applications that are being created. And in this default environment, you end up having lots of shared credentials. And again, these are real examples of a few platforms. And you can see that, of course, as a hacker, this is kind of a very basic privilege escalation, right? Once I have a user for the credentials for a specific user, and I log into one of those platforms, it's jackpot. And this is why we are calling this credential sharing as a service, because this is essentially what the platforms have built. And so this is the first thing that I wanted to show you, and we'll see this again and again when hackers are leveraging the fact that they own an account for a specific user. They log in on behalf of that user to the local no-code platform, and they are presented with a bunch of connections that they can use. They can be connections for that same user or for other users as well. So that's kind of the first thing I wanted to show you. The next up, you can also use those connections to perform actions. And so here's a very simple example. A ransomware attack being done completely with low-code, no-code. So this is a very simple automation. I trigger it manually, and then I iterate over a SharePoint site. And each one of the files in that SharePoint site, I'm going to use an encryption function that is actually provided by the platform itself to encrypt that file and replace the original file with the encrypted version. And again, this is very simple. You can see that I've built this automation with drag and drop. And of course, you might be recognizing a specific platform here, but this actually works across different types of platforms. So again, this is a very easy way for hackers to accomplish their goals without actually writing any line of code. And remember that this is operating on the cloud providers on the SaaS provider's cloud, so it would be very difficult to actually identify. Next up, you don't have to stop with actually creating damage. You can also send information outside of the organization. This is an example which is very, very common. I can't tell you how many organizations that I've worked with I saw, we spotted this example quickly. Basically, there are a bunch of tools out there that organizations have to protect themselves from data exfiltration. So you can find DLP, you can try to create DLP on the network level, on the email server level. These solutions are great, but they can easily be bypassed with low-code, no-code. Here's what's going on here. There are two separate connections to email. One connection is using a corporate account. Another connection is using a personal account. And now, instead of forwarding data between the corporate account and the personal account, which would be flagged by a DLP solution, the data is simply being copied from one connection to the other. This is being copied in the SaaS platform. So there's no way for your DLP solution to actually solve it. No data is actually being moved on the network. So if you would look at it from a network perspective, on one hand, you'll see the low-code, no-code platform reaching out to the corporate data. And on the other, you'll see the same platform reaching out to personal data. But you wouldn't know that these two connections are actually related. And that's what's going on here. This allows users to very easily and trivially bypass data exfiltration controls. One other thing you can do here is you can actually move to on-prem. So there are to on-prem to people's machines. So low-code, no-code has a version of it that is typically run on a user's laptop, which is called RPA. RPA is about automating the keyboard, the mouse, so kind of emulating a user on a user's machine in order to mostly integrate with legacy systems. This also means that some of those connections that are stored on the cloud provider's SaaS service allow you to execute code on the user's own machine. And I actually gave a talk at DEF CON about the kind of the last DEF CON on how these abilities can be used to power a malware operation. You feel free to check it out. And so all of the things that I've just showed here are part of the usual assessment that I help customers do at OWASP. And so one of the things that I wanted to do in order to help kind of people experience this is just create some sort of a tool that allows you to do it yourself. And so I'd like to introduce you to Zapcreds. It's a very simple script. You can find it in the address here. And what it does is very simple. You give it a username and a user credentials to one of those platforms, to Zapier, and it will reach out to the platform and fetch for you all of the different connections that are available for you to use. And it will also show you, as you can see, which credentials are being used by the connection, whether they are the credentials of the users that you provided or some other user, which is overshot. And again, I encourage you to use this tool to educate your teammates and also to play around and understand yourself how do these things operate. Okay, so we've seen what you can do with existing connections. What the next logical step is, how can we fool users, how can we push users to create connections? So if every connection that is available on those platforms is available for me as a hacker to use, the next logical step is for me to entice them to actually create more connections. And so here's the idea. I set up an application that does something useful. That application could be, for example, I'll show you in a moment, but what I'm going to do is take an application from the Microsoft Marketplace. This would be a simple application that creates an out-of-office arrangement. So I tell it when I need to be out of office, and it will decline invites for me. That application ends up creating connections on the fly. It needs access to people's emails, and so it creates that connection when people log in. Now, I'm going to entice users to use it because it's going to be useful. But of course, while the application is running, I have access to their connection, and so I can use it for my malicious purposes as well. Let's see that in action. All right, so I'm going to the Microsoft Office Marketplace. I'm going to choose the out-of-office application. And again, this is a simple application. What it's going to do is, first of all, ask me for connections. You can see, and I'll show you this. I'll get back to this in a moment. So the application is now created. You can see that I play around with this application. Essentially, you tell it when you're out of office. You choose a bunch of parameters. Who should email be forwarded to, and it will accomplish all of that for you. So it will deny calendar events and auto forward your email. What I'm going to do is simply insert a very small kind of a one-liner where I'm using the connection to email, in this case, to send myself an email saying, oops, I've been pwned. Essentially, this is business email compromise, but of course, I'm not going to do anything very malicious in here. And so you can see me typing pretty slowly, but once I finish typing, you'll find that uh, all of you'll find that again, this is a very simple kind of one-liner. Once I'm done, what I'm going to do is save this application. Again, save means deploy. And you can see that's fine, I've saved it. And now I'm going to, this creates a URL at Microsoft. I'm sharing these credentials I'm sharing this application with the entire organization because, well, why not? And you can see that I'm copying the link here. This link is running on a Microsoft domain. And now from a different user, I'm going to go into this application. Once I log in, it asks me to allow access to specific connections that it needs. And then once I'm in that application, I'm a user, I can use that application, and you can see that that my email has been compromised. And so this is a this is a I mean this is an interesting application where you can basically own a user's credentials while they use the application. Now, yeah, so before I move to the next part, what I want you to think about is that, of course, it's true that every application that uses some sort of connection is actually has access to that connection while it runs. But the crucial piece here is that the people that are building this application can be anyone. This is not sophisticated at all. Every business user can do it, and more than that, it is hosted on a Microsoft domain. So imagine a scenario where somebody in your organization that you don't know sends you a link to an application. This application, the link is on a domain that belongs to Microsoft. So the chances of you clicking that link are pretty high. And once you click that link, what you get is this approval window. You can see that this is not the typical OAuth consent approval window, right? It doesn't tell you which permissions it's going to use or which application is going to use it, because this is essentially a full scoped connection to across all of the different services. So across your Office 365, across Office 365 users, which is actually Microsoft Graph behind the scenes. Once I click on allow, the application can do much more than what I think I thought it would do. So it's an out of office application. It should, for example, decline my emails, my calendar invites. But as you've seen, I can also use it to do other things. And so the only thing that is disturbing for me here as a hacker is the fact that there's this approval window. So this is two steps where the first step, in order to compromise somebody's email, the first step I need to do is to get them to click on a link that belongs to Microsoft. And the second step is that they need to click allow. And the question is, can we skip the second step? The unfortunate answer is that this is actually provided by Microsoft. So there's a way for admins to set a flag which removes this window across the entire tenant, and this is being done for productivity reasons. And so, of course, if this is the case in your organization, this is the one-click this is the one-click action that is required from users in order to compromise their identity, again, on a Microsoft domain. All right, so the next up, we understand how much damage you could do with accessing local no-code platform. And then the next question is, how do we persist there, or how can hackers persist within those local no-code platforms? And what I'm going to do in this section is follow a single case that was published about 2 years ago, where an APT group used Microsoft's Power Platform, so the local no-code platform around Office, to persist within a network for more than 6 months while defenders were looking for them. And kind of the scenario here is that they have compromised an IT admin for the network, a global admin, And instead of installing something on their laptop or moving laterally through the network, they created an automation that used e-discovery tools to find passwords and sensitive information, and then just send it off to an exfiltration endpoint. And that automation was still up and running 6 months in because nobody was thinking about looking at that particular area. And you can use this link here to actually learn more about that case. So let's try to see how it can work. So here's a very kind of this is basically a reproduction of what happened in that attack. So there's a flow here that runs on a recurrence, so on a specific frequency. It lists an entire SharePoint site. It encrypts any one of the SharePoint files. It dumps the entire encrypted SharePoint file on Pastebin, and then it tweets about it because why not? Nobody will find me anyway. And so this is a nice example of kind of of the same thing that happens with attackers. Let's try to take it one level further. So instead of running this on a recurrence, let's run this with an HTTP webhook, so I can just trigger this whenever I want as an hacker. And one of the things that you'll find is that these webhooks that are put out there by those platforms are actually not authenticated. So there's a secret you need to know in order which is created once you create the webhook, but that's it. And so you can fetch it from Tor or wherever you'd like. So again, this is a slight improvement on what you've already seen. And so now that we've gone one step further, let's try to think, what do we need in order to persist as a hacker? What are all of the things that we need in order to actually persist in an organization? So the first thing we need is remote execution, which is kind of obvious. The second thing is that we would like to be able to run arbitrary payloads. So not just a single payload, but every type of payload that we would like. We would like to maintain access, even if the user we initially compromised is no longer available. We'd like to avoid detection, and in case we get detected, we'd like to avoid attribution, and we want to leave no log behind. Let's see how an attacker could accomplish all of that with low-code, no-code. So first of all, let's see what we already have, what we had in the previous example. And so this HTTP webhook is, of course, a persistency mechanism, right? Because you can just send out those requests without having to still maintain the login for the specific user that has created that automation. And so we have remote execution here. What we don't have is, of course, arbitrary payloads, because this is a specific payload to exfiltrate, in this case, a Google Drive. So let's see if you can make this better. Of course, one thing to note here is that maintaining access is also covered, because again, the only secret here is the little UID that you're seeing here inside of the URL. So you can just call it without authentication. Avoiding detection is also pretty easy. There are no logs that are easily generated by somebody creating that webhook. And even if there are, this is somebody else's cloud, so it would become very it would be very difficult for you to actually gain access to it and view that information. Avoiding attribution is even easier, because that endpoint can be used from an anonymous source like Tor. So that's, again, pretty easy. And logs, well, not so much. So these automations are actually generating a whole bunch of logs for each one of the calls that is being performed to these endpoints. And so we'll see in a moment how we can circumvent that. And so let's try something else, something more advanced, to cover the 2 points that we have here: arbitrary payloads and logs. And so instead of running one payload, why don't we have one HTTP endpoint that allows us to run multiple different payloads? And you'll see a few different payloads that I've created here. So leak an entire SharePoint, leak attachments from Outlook, execute a stored procedure in SQL, and others. And so let's think if this actually solved our problem. So unfortunately, no. So these are more payloads, but these are definitely not arbitrary payloads, and we are still generating logs. And so let's see how we can solve both of those problems. This is what we're going to do right now. And the key insight to solve both of those problems is that low-code, no-code platforms allow you to manage themselves with low-code, no-code. So you can use, for example, a connection, that connector called Power Automate Management, to create and run and delete Power Automate flows. And this is the same for other low-code, no-code platforms. So let me introduce you to a tool we are calling Powerful. And again, this is available as open source. You can play around with it, which is creating this persistency endpoint within the Microsoft 365 low-code, no-code platform that allows you to run arbitrary payloads. This is what it looks like. So there's a single HTTP endpoint. Once you send off, instead of sending a specific a command to run a specific payload, you actually send the definition of the payload you'd like to actually operate. And then what this automation does is three things. It creates the automation, it runs the automation, and then it deletes the automation. And you can see that there are a few different types. There's also one other operation that we're allowing here, which is to list available connections or available credentials that can be used by that automation. So this is the entire automation. You can see that it has these three separate operations. And of course, because we wouldn't want to play around with this, we want this to plug into the rest of our red team arsenal. There's also a nice little REST API and Python wrapper Python CLI that wraps everything here. So again, feel free to play around. This is you can see that the step that this takes here are pretty simple. You create this, once you install this persistency endpoint somewhere, you create a connection to that endpoint. You fetch all of the different credentials that you can use. You create an automation that uses those credentials. You run that automation, and then you simply delete it. Now, the important piece here is that we have solved both the arbitrary payloads and logs part. The arbitrary payloads is, of course, solved because you can just create any payload you'd like. And the other thing of logs is that the logs are actually saved with the automation itself. So by deleting the automation, the logs get deleted as well. All right. And so up until now, we saw attacks that required you to have initial access to the platform. Let's now dive into a couple of attacks that don't require any access at all. So attacks you can do from the outside looking in as the first vector of attack. One common thing we've seen in the industry is attacks where there's a predictable misconfiguration that can be leveraged by hackers. And so so one example you could have in mind is AWS S3 buckets. For years, the default setting was that they were available to anonymous users. And so people made the mistake of leaving this default on. And then hackers can easily scan open S3 buckets and steal sensitive information. So let me show you a parallel in the world of local no-code. Power Portals or Power Pages in their new name are a type of low-code application in the Microsoft 365 suite. And they are essentially a public-facing application that is built on top of a managed SQL Server instance, so business data. These applications are used for public-facing endpoints. You can see a real example here. And these can be used, for example, to onboard new vendors into your company, or every time somebody visits your organization physically, they need somewhere to log in. So this would be these types of apps. And because these apps have to be used, they need to be kind of websites. So you can use them anonymously. There's a default setting where anonymous users can actually access information in a specific location and a specific there's an API that is being exposed to these anonymous users. One of the challenges here is which data should actually be used, should actually be accessible to those anonymous users. So the website would have authenticated users, which should have access to their identity, to their data. And it should also have anonymous users, which should have access to very limited data. The problem here that the team at AppGuard has found about a year ago was that the default configuration was such that every table that was being used by this application was available to anonymous users. This includes tables that should be available to admins only, or that should be available to authenticated users only. All of those were available to everyone. So let me show you an example of how this looks like. By the way, before I get to the example, the default setting, once the team at AppGuard found this, Microsoft was very quick to react and change the default setting. So if you create a Power Page app today, the default setting would be secure. It doesn't mean that users cannot change the default setting to make it insecure, not because they want to, but because they made a simple mistake. So let me show you an example. So here's an example from a real application. This is an application for a financial services company, large and US based. You can see by going to the API endpoint, I get a list of all of the different entities or those objects that are available for me to query. Default is not really interesting. There's nothing there. Entity form set is just the way that the form submissions are being stored. But you can also see this nice little global variables object. And when I go to this global variable object to find out what's there, of course, I get authentication tokens, and specifically authentication tokens to Azure. And so, of course, this is available to every anonymous user. This was actually disclosed to the relevant company, and they have fortunately solved it quickly. Now, the crucial piece here is that this is not a one-off thing. All of these applications, these Power Automate, these Power Pages apps are available on the same domain in different subdomains. So, of course, as hackers, the very quick things we can do is to enumerate those subdomains, which would allow us to get a list of all of the potentially vulnerable apps we could exfiltrate data from. And because this is Microsoft, we can use Bing. You can see that a very simple query finds a whole bunch of these applications that could be available with this vulnerability. And so a very short recap of what we actually what we found here. So we submitted multiple vulnerability disclosures, and the type of data that we found was emails and names and information about specific people. We found secrets leading to Azure and to AWS, and we found a whole bunch of the business data, including records and receipts and PDFs. And so this is kind of one example, and there are other examples where predictable misconfigurations can be used by hackers to access business data because it's available by default or because somebody has made a configuration mistake. Now, let's do a quick summary before we talk about how we can stay safe. So we've seen that low code is huge within the enterprise. There's no real choice there. You have to, if you work at a large enterprise, you have low code, no code, and your business users are already using it. And it could be because you have brought it in yourself, or because the platforms that you already use have built low code, no code on top. We've seen that in many cases, low code, no code platforms are underrated by security teams, and that they are lacking the way for you to monitor those platforms is severely lacking. And we've seen many ways in which hackers can take advantage of low code, no code to breach an organization. We've seen several living off the land techniques where hackers can leverage these existing connections in order to steal information or do damage within your organization. We've seen that low-code, no-code platforms can be perfect for a persistency mechanism within an organization. And we've seen that predictable misconfigurations, such as the ones we see in cloud, pop up again with low-code, no-code and expose business data outside of the organization. We've seen a couple of tools that you can use. And of course, the idea here is that you'll use those tools to educate yourself, educate your teams against the threats, and create detections that would be able to catch those types of issues. And so the last thing I'd like to do today is to give you a very quick kind of point on how you can defend your organization against what we've seen today. So the first thing I really suggest you go ahead and do is to review configurations for these low-code, no-code platforms. In many cases, the low-code platforms or their particularly worrisome features can be flagged or limited in a way that would reduce your risk. In particular, I highly encourage you to, if you're using Microsoft, highly encourage you to look at this bypass consent flag, which can expose you to significant risk. I also encourage you to review and monitor any external facing endpoint that has been created on your behalf by these local no-code platforms. Those would include webhook URLs by different automations, the OData or the API behind that is being created by Microsoft for Power Apps, and for other platforms are the same kind of things. These are endpoints that expose your data or your operation that somebody else's manages. The third thing I advise you to do is to review those shared connections. Go to those different environments, understand which low-code, no-code platforms your organization has, and review those shared environments to find shared connections and purge them from the organization or reduce permission to those connections. And if you're thinking of how do we use low-code, no-code in a secure way, in a way that on one hand allows the business to continue to operate and to push forward to accelerate productivity, and on the other hand we remain secure, I highly encourage you to check out the OWASP low-code, no-code top 10. It's a growing community of over 200 security professionals. There are a bunch of voices there from different perspectives, and you'll find a whole bunch of examples of attacks that were found in the wild and were not covered in this talk in the OWASP top 10. So thank you very much.